Hello and welcome to the Tuesday, October 21st, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich, recording today from Jacksonville, Florida. And this episode is brought to you by the SANS.edu Graduate Certificate Program in Cyber Defense Operations. In Diaries today, we have Xavier talk about Python malware. Well, that's of course Xavier's thing. And this time, Xavier ran into interesting Python malware that uses Syscall. Syscall, of course, can be used to call operating system functions. In this particular case, it calls a function that will create a file handle in memory, allowing for the malware itself to write then into memory, creating fileless malware. Now, the malware itself is not really that remarkable, as Xavier points out. It appears to be more of a proof of concept. It implements sort of some pseudo ransomware in the sense that it encrypts files with a 1-byte XOR key. So something that would be rather easy to brute force and then to decrypt, which probably could, of course, then after they sort of got that fileless part working right, be replaced with a more sophisticated encryption feature. This particular malware is somewhat recognized by various scanners according to VirusTotal, but still not a great sort of detection rate here, even though that call to Syscall should be somewhat suspicious the way it's being used here. And of course, the big news today was another outage at AWS, apparently affecting the US East 1 region, which usually tends to be one of those crucial regions. If it fails, well, many other things fail as well. There are a number of different sites and services that were affected by this outage. And if you had problems going to any number of different websites or using services and the like, you probably ran into some issues today. SANS.org was also affected by this outage. At this point, Amazon states on their service status page that they're sort of back to normal. I want to emphasize here a little bit the sort of part, because they're still apparently throttling any new creations of systems and such and workloads to Lambda and the like. So this still means that even though Amazon is running, they're not running at full capacity. And of course, they figure out which services they shed. And as a result, many of their customers still aren't able to sort of operate their sites at full capacity. Now, I've sort of seen this, in particular with the SANS.org website, sort of go off and on again all afternoon today. And as a result, like I said, you may have seen a maintenance message there. The ISC site, isc.sans.edu, is not running on Amazon, so it happened to respond. This is really one of those common things that we have where we do have these bottlenecks that a lot of traffic goes through. Amazon's US East 1 is one of them. Of course, Cloudflare being a similar one. If one of these services is down, it really affects a large percentage of websites, services being hosted via these particular resources. As a user, there isn't really much you can do as a service provider using these services. Of course, you always have to think about redundancy. It's not easy, it's not cheap to create redundancy, and that's really what it comes down to, sort of a business decision, whether or not it's worth it to you to maybe sort of, cover that. I'm not sure what it is. It appears to be sort of once a year or so where we have these major outages. Another item that created a lot of news headlines today was allegations by China that the US, in particular, they allege the NSA did breach the systems responsible for maintaining the Beijing Standard Time. In the US, of course, there's also a similar standard time service operated by NIST and the US Naval Observatory. I want to stay a little bit away from the politics here and whether or not it happened or what exactly happened. The write-up of the breach is certainly interesting and something that you should look at because it illustrates one of these sort of more complex and persistent breaches and what techniques are being used there is certainly something that you sort of should read up on. But I want to focus here on the real reason why I decided to cover this, and that's NTP is sort of one of my favorite protocols and time standards in general, because I find they're often a little bit sort of an overlooked Achilles heel of network security. A lot of network security protocols, whether it's Kerberos or many authentication protocols, are relying on NTP and on accurate time synchronization. Now, there are a couple other standards as PTP, sort of a more local network protocol that's often used for time synchronization. Typically, time synchronization actually happens in UTC and not in a specific time zone. I'm not sure Beijing not having daylight savings time and also only having one time zone across China. For them, it may make more sense to use something like Beijing time as their internal standard instead of UTC. But what it really means is that you must control your time standard. And there are really two things that you need to worry about. Most of all, you need to worry about having a consistent internal standard so that all of your internal clocks are in sync. That's usually best done by having one or two internal time servers that all of your systems synchronize to. I've sometimes played DNS tricks because so many systems by default use time.apple.com or Microsoft.com or the pool.ntp.org NTP pool for time synchronization, and it can be difficult to get them all configured to use the correct internal time server. So just DNS tricks can sometimes direct them to your internal time server. There are options to digitally sign and encrypt these time signals. That's certainly something to consider. The second part is synchronizing your internal standard with an external standard. And that's where you kind of need to look at, first of all, diversity, use several standard clocks that you're synchronizing with. Look at who you're synchronizing with. The pool.ntp.org has been reliable in the past, but anybody can sign up for it. Now, most NTP servers, all I know for the most part, are able to reject certain clocks that are out of sync, and that's certainly something then to consider. I've did some measurements about this in the past, and I probably should publish something about this again when I get around to it. The other thing, of course, the other option you have is GPS, and that usually works really well and is not really that terribly expensive to implement. But then always, whenever that external standard fails, you then rely on the internal clock being reasonably accurate. And that's where the very cheapest clock may not necessarily be what you want to use. And depending on the size of your organization, spend a little bit more money on a decent standard clock that then maintains the time in case external references fail or drift too far. And that's, again, usually a configuration item for NTP servers where you can reject external clocks, not just because they're out of sync with other external clocks, but also because they would adjust your internal clock by too much of a step. Certainly something to think about and to look at the architecture of your NTP distribution in your network. Well, and this is it for today. So thanks for listening. Thanks for liking. Thanks for recommending this podcast, and talk to you again tomorrow.